Hi, discrete math class. We are going to work on some problems, and I am looking at your textbook at problems 67 to 78 on page 77. And those are great problems to look at. And it's a little twist on what we did yesterday, except now we're going to be using a Venn diagram. So in order to start this, what we'd like to do is we'd like to draw a universal set. Remember, the universal set is the set of everything that we're talking about. Then what we would like to do is we want to put two sets that overlap, so that have something in common. We're going to call this set A. We're going to call this one set B. Alright. And we're going to have the following things in each set. Pardon me. I don't want a fraction bar there. So ignore that fraction bar if you can. 1 and 4. Then 3 and 7, and also 2, 5, and 6. So our universal set contains these numbers plus 8 and 9, which are not in the set. So the universal set is the digits 1 through 4. Or excuse me, 1 through 9, and those digits then are listed in various sets that we can see here. So now our challenge is to just write what each set is. So for instance, I would ask you what set A is. So set A, listed in the roster method. The roster method contains the elements 1, 4, 3, and 7. Alright, does everybody see that? So why don't you do that? Tell me what set B contains. So, after you've done that, you can see that set B contains 2, 5, 6, 3, and 7. Okay, so not very difficult. So our next challenge then is we can start to play around with this. Well, what would be something like B complement? Well, B complement would be the elements that are not in set B. So what's not in set B? Well, we can see 2, 5, 6, 3, and 7 are in B, but what's not in B is 1 and 4, but also 8 and 9. 1 and 4 are in set A, but not B, and 8 and 9 are in the universal set, not in A or B. Alright? So that would be the complement of B. Another example would be to do like a union. So we could do, how about A complement union set B? Alright? So what's that equal to? Well, we have to kind of observe what we're looking at here. So A complement would be each one that is not in set A. So let me use the blue marker here, and you can see that 1, 4, 3, and 7 are in A. So with the red marker, the elements that are not in A are right there with the red ones. And then I want to union those with set B. Alright? So the union is going to be everything in both sets. So I can see that obviously it's going to be everything in A complement, 2, 5, 6, 7, 8, and then also everything in B. Well, 2, 5, 6 are in B, but so are 3 and 7. So I would include the 3 and 7 in this union, everything together. Okay? Okay, for the final slide here, I've put the same universal sets A and B. A has 1, 4, 3, 7. B has 2, 3, 5, 6, 7. And outside of A and B, but in the universal set, are 8 and 9. So what I would like for you to do is pause the video, and I would like for you to solve this problem, A intersect B, this problem, A union B complement, and then this problem up here, which has a new notation. It says A union B, but what's the N in front mean? Well, the N in front means find the cardinality of A union B, or if you wish, the number of elements in A union B, and that's why we put a little n in front. So I'm going to let you solve those. I'll pause the video and I'll give you a moment to work on them, and then you can come back and tell me what your solutions are. So let's do the first one. A intersect B visually is going to occur where A and B overlap. So the intersection is always everything that's in A and also at exactly the same time in B. And we can see from the diagram that the only possible elements that satisfy that are these elements right here, 3 and 7. So we can go ahead and write that our solution is 3, 7, the set containing those. So what about A union B complement? So one of my tricks when I do a problem like this is I just want to find A union B. Well, A union B I can see is 1, 2, 3, 4, 5, 6, and 7. It's everything that's in A and B at the same time. And you can see that quite easily right here, 1, 4, 3, 7, 2, 5, and 6. Those are all in A and B at the same time, so that's A union B. And then what I do is I just put a little complement there. So what's the complement of 1, 2, 3, 4, 5, 6, and 7? Well, in my diagram, it's everything that's not in that set. So my final answer would be 8, 9, the elements that are not in the union, and that would be the final answer. Kind of fun, nice little trick I have there. So let's look at the number in A union B. Now, before we just found what A union B was. It's 1, 2, 3, 4, 5, 6, and 7. It's the set that contains those 7 elements. So what's the number in that set? Well, the number in that set is 7. So if you were able to do those problems, you understand this well enough, and you can move forward and prepare to do your lessons tomorrow. There'll be a set of homework. There'll be probably problems starting somewhere around problem 79 and going up through 108. I'll pick a few problems out of there. So you can look those over and I'll tell you which ones we're doing tomorrow. It'll be about 10 or so. All right, we'll talk to you later. Bye.